Hello, everyone. Thank you very much for joining us today for the Innovation for Cool Earth Forum 9th Annual Meeting hosted by the Ministry of Economy, Trade and Industry and New Energy and Industrial Technology Development Organization. Now, let us begin the side event, the second roadmap event, Blue Carbon. First of all, I'd like to introduce the moderator for this session, Mr. David Sandlow. Mr. Sandlow is a steering committee member of Innovation for Cool Earth Forum, the inaugural fellow at the Center on Global Energy Policy, and co-director of the Energy and Environment Concentration at the School of International Public Affairs at Columbia University. And now I'd like to ask Mr. Sandlow to moderate the session. Mr. Sandlow, if you please.
Thank you very much. It's great to be here. Hello to everybody in the room. Hello to everybody around the world who is joining in with us today. I'm delighted to be moderating our second roadmap session for this Innovation for Cool Earth Forum. The ICEF Innovation Roadmap Project is now 7 years old, and we've produced 10 roadmaps. The first roadmap was produced back in 2015, 2016. And we've been producing one or two every year since then. We've covered a wide range of topics. Last year, we did a roadmap on carbon mineralization. The year before that, we did one on biomass and biomass carbon removal and storage. The year before that, we did one on industrial decarbonization. And before that, we did one on direct air capture. And there have been more going back. And Mehdi and Nito have provided tremendous support for this process. And this year, in honor of the 10th roadmap being developed, Mehdi released a booklet, which you can get a print copy of at this conference if you're here, or it's also going to be online. And it has statements from leaders around the world talking about the impacts of these roadmaps. And it's been wonderful to see. The chairman of the Intergovernmental Panel on Climate Change, Ho-Sung Lee, and a number of other leaders around the world talk about the contributions that these roadmaps have made. Earlier at this conference, yesterday, we released a draft of a roadmap on low-carbon ammonia, which is a topic people I found know very little about, but it's a topic that can contribute to decarbonization. About 2% of global greenhouse gas emissions come from the production of ammonia. And we can reduce those, and then we can use low-carbon fuels we can use low-carbon ammonia to replace carbon-based fuels in shipping and the power sector. So yesterday, we released a draft of that roadmap. It's available on the ICEF website. It's open for public comment until the middle of October, and then we're going to release the final version of it at the Climate COP in Egypt this year. So that's the background from ICEF's standpoint for this session today, because we have an 11th ICEF roadmap in the works on a really important topic, which is blue carbon. It's how do we use the oceans to help capture carbon and help to mitigate climate change. And of course, the oceans are an extremely important sink to begin with from a geophysical standpoint, absorbing lots of carbon every year. But how do we augment those processes? How do we make the ocean? How do the oceans play a major role in fighting climate change? What are the technical aspects of that? What are the social aspects of that? What are the financial, economic aspects of that? That's what this roadmap is looking at. We have, for this session today, we have 3 leading experts on this topic, and we're really thrilled to have them. And so I'm just going to introduce them right before each one of them speaks. And then if we have time, we're happy to take questions from any of you. And our first speaker we're really honored to have is Atsushi Watanabe, who's a senior fellow at the Ocean Policy Research Institute at Sasakawa Peace Foundation. Mr. Watanabe, the floor is yours.
Yeah. Moderator Sandaro-san.
Mr. Sandalo and all the audience on the site and also online, thank you very much for joining us. And I am Atsushi Watanabe from the Sasakawa Peace Foundation.
I hope maybe okay. Then
Can you hear the translation? So since there's a lot of Japanese audience, I would like to speak in Japanese. So I would like to talk about the outline of the blue carbon roadmap of ICEF. Blue Carbon Roadmap is titled Carbon Captured by the World's Coastal and Ocean Ecosystems, and that is the title. And this title indicates that the blue carbon will be one of the negative emission technology through the mangrove and also the tidal marshes and the seagrasses in the saline area. There's a sink of the carbon already, and also there are the macroalgae, the culture, and also the ecosystem in itself. It captures the CO2, and that's the subject of our the roadmap, and we envisage the potential of the blue carbon towards 2030 and 2050. Beyond that, and we would like to acquire the MRV for carbon credits, and we would like to innovate the technologies and use it further for MRV. And that's the gist of our activities. And so there are contents as described on this page, and I would like to go over each and every one of them. Next, the first chapter is an introduction about the blue carbon from its the birth and how it progressed is being described. And on the far left, in 2009, UNEP compiled a report on the blue carbon, and the Carlos Dr. Carlos Duald played an active role in the formulation of this report, and that was the, in a sense, the inauguration of the activities surrounding blue carbon, and so the policy and the science propelling forward as two wheels of a vehicle, and then there was the COP. UNFCCC, the Triple C, under COP, they had discussion to include the blue carbon as an inventory to include it in a guideline, and that was a request made. And so the IPCC guideline was formulated by the scientists, and it is so-called the marshland guideline. Now, that allowed us to be able to seriously deal with the blue carbon, and in COP 21, then in NDC, nationally determined contribution, the countries started to adopt blue carbon as part of the countermeasure for climate change, and after that, IPCC repeatedly published the special reports, and in that blue carbon always appeared in a chapter. And so in the chapter 1, this is the compilation of the how it started and how it progressed as part of the climate change countermeasure. Now, how much the global understanding has progressed is compiled in this one chart, and this is rather old, published in 2018, but this is called Established Blue Carbon. Mangrove and tidal marsh, seagrass have already been admitted as established blue carbon, and it is also in the marshland blue carbon, and there are new types of emerging blue carbon, such as the macroalgae and also kelp, and how much these emerging blue carbon is being understood by the scientific community is described here. And there's a good understanding on the established blue carbon, and when it comes to macroalgae, which is one of the blue carbon, the scientific understanding of how much zinc it can attain is not fully understood, and so this will be covered by Dr. Carlos Duald later on. And now after talking about where we stand in the Chapter 2, and the Chapter 3 covers the current and future technologies to scale the blue carbon and how to make the blue carbon one of the significant countermeasures for the climate change. And also there are some concerns over the blue carbon also covered in Chapter 3. And technology covers how to create the blue carbon and how to protect it, and also how to use it, and also how to measure. And these 4 technology-related viewpoints are covered in Chapter 3. And so when it comes to production, of course, there's the seedlings production, and also in order to scale the farming, there's the floating platform being used, and there's a technology over how to create them or produce them, and also integrated multi-tropic aquaculture. And this is technology to culture both the algae and also the fish at the same time. And also there's the offshore wind and the kelp farm, how to make it happen at the same time would require further development. And in regards to the technology to protect, it is rather limited, but the algae are under the threat by the grazers. For instance, so the urchins can be cultured on land so that the algae can be protected. And the technology to use next as food and also as bioenergy and feed and fertilizer and cosmetics products and drugs. And there are a lot of potential for these the blue carbon related algae as new materials. And next is the technology to measure, and there's airborne radar and also auto drones, automatic identification of macro algal bed, and also there's in situ real-time monitoring technology will be expected as technology for measurement. And this is about the environmental concerns. And so ICEF2018 roadmap is what you see on the slide, and the red where there's a risk or the risk identified, and such as the risk of reversal and by the loss of the biodiversity, then this accumulated CO2 may be released to the air. And also so basically the large scale the macroalgal farming on deep sea biological communities may have the risk. And although this will work as the sink, but at the same time we need to consider the risk in the deep sea environment and the ecosystem, and the life cycle assessment is important. So for instance, for the large scale macroalgal farming, and the algae will be dried, and the drying may involve the CO2 release, and how to integrate it to minimize the CO2 emission, for instance, is something we need to study. Next, the Chapter 4 is about the policy and also the regulatory framework, or the systemic framework, and this will be dealt with in IPCC, and only the United States and Australia are the only 2 countries which are making the reports worldwide. And so once this spreads across the industrialized nations, then we will be able to share it and scale it to the developing countries as well. And also, IPCC also has a guideline, but then the large algae, the macroalgae, is still not included. So we need to also review and renew the guideline itself, as the new the sources of algae might be included in the future. And also there's the possibility, the requirements under London Convention or London Protocol. We need to look into that. And also the core carbon principles. So the focus should not be only on the carbon sink, but also at the same time we need to think about the protection of the environment. So we need to stick to the principles. And also, I believe that later there will be some elaboration by the speaker about the coordinate with other stakeholders in sea areas such as fishing communities and port managers. And this is the last chapter, chapter 5, and this is about the storage and also the crediting, how to work on it. And on the left side, this is in Japan, and these are the sink and also 2030 potential. And the blue part is something, the area I would like you to focus on at the moment. It is 132 million to 404, and that is considered to be the carbon sink. But then, so we would like, there's a potential that we can increase it to 157 to 518 million tons. And so these capture the CO2 or stored CO2. There's the credit is to be done by JBE, and 65 tons was covered in 2022. We would like to increase it to 10,000, and then in 2030, and 100,000 in 2050 worldwide. So it is said that the CO2 tip 0.32 to 0.89 per year by 2030 potential, but it may be increased to 0.4 to 1.5 gigaton per year, and this also includes the potential macroalgae. And when it comes to crediting, as of 2020, it's about 300,000 metric ton per year. Now, with the voluntary carbon market, VCM framework, how to increase it? 15-fold by 2030 and 100-fold by 2050. That's one assumption, and we need to see about that. So that is all from me. Thank you very much.
Presentation. It's going to be a real contribution when this roadmap is out. So thank you for that introduction to what's coming. We'll come back to you, and our final presentation is Professor Ryo Kosaka, who's at the Graduate School of Agricultural and Life Sciences at the University of Tokyo.
So thank you for having me today. Today I would like to talk about the social and policy science aspects in this presentation. Two takeaway message is that currently blue carbon is basically dominated by natural science. But we would argue that the social science, policy science issues are key in expanding the scope and moving these things forward. With Dr. Watanabe and Jay, we are writing this roadmap, and I think it's likely to be in the chapter 4, but these elements are quite going to be very important. So social science aspects are the key. And the second point I would like you to raise today is also collaboration with practitioners, and local communities are the other key. So this is my record. You can look at it. And currently we're in the forestry science faculty, but we work a lot in the mangrove issues and also try to link these issues with the coastal ecosystem as well. Jay Marr, who is a co-author with me, has a background of marine science, but in the natural science, but he shifted to social and policy aspects. So I'm going to skip this part, but blue carbon is not only about carbon. It's also about supporting, providing livelihood. It's also about providing habitat, and it's also about culture. And people do rely on these resources. And if you imagine you go to Philippines, Indonesia, or even Yokohama and ask people, what are these seabeds or marsh doing? Well, I don't think the carbon would be the first thing people would answer. I think it will be like, oh, the views are nice, or we use that for timber. We use that for some bees are living there, so honey production, things like that. So I think these are the elements that we shouldn't really forget about. So there are multiple elements, but we're facing various threats: urbanization, reclamation, and interestingly, we think that development of aquaculture are a big threat. It is a big threat, but abandonment of these aquaculture is also an issue. So it's not only these aquacultural ponds are expanding, but they are also getting abandoned. It's a little bit like the rice paddy fields in Japan as well. So that's another element that we also need to think about, and we need to think holistically about these issues. So with this map, I want to highlight, you see the red bars, these are natural science. And if you see the yellow bar, that's social science. So can you see the yellow bar? It's a little bit difficult to catch up, and these are the areas. So I think Watanabe-san mentioned Australia, United States are the ones who could report to UNFCCC. And the rest of the world are sort of catching up. And you can see that there are a lot of papers coming out, but mostly in natural science fields. The data is only until 2019, so this may have changed a little bit or may have improved. We are trying to contribute with some of our papers. When we do that, we try to provide the insights into the current situation. If we see that from local community perspectives, what are their views of so-called blue carbon ecosystems, and what are their linkages to these ecosystems? I'll give you a short example, which on the left-hand side you see the Philippines, and on the right-hand side you see Indonesia. And obviously, for example, if you go to the area where, for example, Philippines, the yellow parts are people are not aware of these ecosystem services. And if you go to the area where people eat, for example, seafoods, they're much more aware of these ecosystems, which is obvious results. But so what I want to argue here, and there is a lot of difference between mangrove and seaweeds or seagrass beds. So we cannot just say blue carbon ecosystems. Well, we need to approach different communities, what their linkages, what their relationships with these ecosystems are, and also we need to take into account what are we talking about, mangroves, or are we talking about seagrasses? So these are the things I think we need to think about trying. And one more collaboration with natural science is which could be quite interesting is we did a participatory GIS analysis, and we basically looked things from the satellite image, and we also asked about the perceptions. And it can differ actually a lot more. And of course, if it's closer to the road or if it's closer to the community, people tend to think about it much as a larger things. Or people tend to also forget things which happened in the past. Or so the perception and the objective or seen from the satellite image may differ a lot. So that's another gap that when we think about the communication that we need to keep in mind. The other thing is blue carbon. We only mostly talked about only the coastal parts, but blue carbon, it's very difficult to capture with the satellite image or other from the above image. So I think Carlos and Dr. Watanabe can also explain these issues. But I think that's the specific challenge for the blue carbon issues, and that's I think where economists, sociologists, or even anthropologists can contribute to these discussions. Regulations. Carbons are not so much in. This is in the case from all the states in Indonesia, but carbon is not very much referred to, and a lot of issues are like banning. You should not do this. You should not do that. That's the kind of the regulation that tends to go into, especially in the developing countries. But is that going to work? Well, we have to talk to the community and think from the community's perspectives. Otherwise, that's not going to sustainable. So you cannot really do the top-down, you shouldn't do this type of approach. It's not going to work. I think that's the experience we had with the developing projects in the past maybe 50, 40 years. So when approaching blue carbon, I don't think we should say you shouldn't do this in mangrove, you shouldn't do this in coastal zones, but we should give an incentive. We should give a freedom or ownership to the local communities. I think that's something we need to think about. The situation is pretty much the same in the Philippines. In a nutshell, I think there not much awareness about the carbon, which is, I think, a natural phenomenon for the local communities. For them, it will be much more about livelihood. It's about the provisional services. It's about how much fish they can get from these areas. But we need to come up with some kind of a bridging of these global benefits and the local aspects. And I think, for sure, this roadmap is going to be one of the keystone publication bridging these two scales or three layers of scales. And we also need to take into a consideration what are the real situations in developing countries, because these are the areas that we need to approach, and that's where the blue carbon conservation efforts can, I think, enhance and so on. So thank you very much for listening. I think I left some time for a question and answer discussion.
Well, thank you to all three of our speakers for such fascinating presentations. And just one quick follow-up question on the timing for this roadmap. When should people look for it? Is that Mr. Watanabe?
タイムライン、はい、すみません、説明を忘れてしまった。
So about the timeline, so this public comment is going to run for 15 days until October 15th. And so in mid-November, we will present the draft in the COP UNFCCC, and may have another public comment period after that. And at the end of December, we will have the deadline. And according to, depending on how much the work progresses, it can be the early January, the deadline.
Thank you. It sounds like you've got a lot of work ahead of you. So, but we're all going to benefit from that. So thank you very much. Let me just remind you, if you have any questions in the room, you can just raise your hand, and we've got a microphone. On Zoom, you can send it in. I have a blank screen in front of me, so I'm not seeing any questions that might be sent in. So just as to let the organizers know. Let me turn to some of the issues that Professor Ryo Kosaka was raising, and in particular the connection between the natural sciences here and the social sciences, because it seems like any strategy in this area is going to involve integrating the natural sciences and the real and the social sciences. And I wondered if you could say some more about that topic.
So I think one of the area is the validification or monitoring areas and linking that with an economic measures and giving incentive to local communities. I think we have some finance people in the room, and that's I think we Dr. Watanabe mentioned it's going to increase by a factor of 15 to 50. So that's definitely one areas. And also we need to involve the weak or the marginalized communities, and we need to reflect these views also into the analysis. But one area definitely that would be these linking of validification, monitoring, and the economic measures. The others would be, I think, the AI type of identification, how accurate they can actually develop with the drone images and so on. So I think that's one interesting area.
That's great. Well, actually, your mention of drones reminds me of there was a brief discussion about satellite monitoring and the limitations of satellite monitoring. We've really made great advances in remote sensing of carbon detection and other pollutants generally, but who can best speak to this issue of remote sensing and measurement of carbon, of blue carbon.
Me? Oh, okay.
Mr. Watanabe, yeah, please.
Yeah, so thank you for the question. And so as we discussed, we cannot monitor the carbon sequestered in the sediment itself.
Yeah.
But so we need to make an equation tailored to each ecosystem or each region, how we can link the satellite imagery captured data and the real sediment carbon stored in the ecosystem. So, and actually IPCC is reporting the kind of a tier 1 to 3 type of equation tailored to each region. But we need to develop more sophisticated equation, which can be used for each region. In the case of Japan, we are now developing that kind of equation. And also for seaweed, we don't have that, so we need to develop that. That's, I think, a situation. And for that particular activity, as he said, Kosaka-san mentioned, we can involve the local stakeholders for the monitoring or the reporting activities of the blue carbon.
Great. Let me just give anyone in the room an opportunity who'd like to ask a question. Yes, please. We have a hand raised right here. And please identify yourself.
So my name is Miyamoto from Jinnen, and I do have a question. Within the explanation related to the presentation. So within the seabed, if you were to sequester the carbon, you mentioned that there needs to be ongoing monitoring, and also there needs to be evaluation of the carbon being sequestered. So let's just say if the carbon, what are some of the conditions or the seabed conditions that can sequester carbon? Is there a discussion per se that what would be the optimal condition for seabeds to better sequester the carbon? So may I? Or maybe Carlos can jump in afterwards, but I would like to make the initial comment. So as mentioned, so unlike a normal forest, in terms of the ocean, there is a sediment on top of each other. Therefore, wherever the sea level is stable, then there's where there's a stable development of mangroves or the algae. They have been able to have the sedimentation for a couple hundred years under those stable sea level. However, if there are some changes in the sea levels or if there are some human activities, that may also change the condition. Therefore, the changes in the climate conditions may also pose a difference. So up until now, in the coastal area where the ecosystem is relatively stable, that has been the optimal area for the carbon sequestration. May I add on? Or actually, I'd like to. So in terms of the seaweed aquaculture, would it be a completely different site because I believe in terms of the aquaculture farm, perhaps the carbon sequestration condition may differ. So that was my question. Oh, okay, I understood. So this is about the aquaculture. So this was said in the Carlos presentation. As we speak, there has been evaluation and research on different farms. For instance, the Bay of Tokyo, where the operation has been ongoing for 300 years. And there has been research on what sort of the condition has been sustained. What is the kind of carrying capacity has they had? So they have been doing that. So scientifically, we need to evaluate and discuss. So going forward, we need to take more of a scientific look on the condition to operate the aqua farms.
Everybody is talking COP is UNFCCC, UNFCCC, but there is a CBD, Conventional Biological Diversity COP in December, which decides the target, next global biodiversity framework until 2030. In that, we're going to discuss OECM, I'm sorry to introduce another acronym, but other effective conservation measures, which includes privately owned lands or fish, I think the aquaculture lands. So involvement of private sectors are going to be another key issue, also in the context of biodiversity. So that's something I want the audience also to know. Thank you very much.
Well, that's a great note to end on, and this has been a fascinating presentation. This roadmap is going to make an important contribution to the literature on this topic. Professor Duarte, especially want to thank you for waking up extremely early in Saudi Arabia to join us. Please join me in giving our speakers a big hand.